Mm. I checked this yesterday. All right, good morning. Happy Friday. How's everybody today? I am okay. For starters, let's see who's here. Um, all right, Malik and Piper. You and who's this? Okay, Malik and Piper, you need to do your assessment on the gizmo. So while we're waiting for folks, you could knock that out. Uh, we're going to let's see who else. That's it. Everybody else who's here. I have you. All right. So those of you who already did your assessment, and that's on the dichotomous key gizmo. If you've already done that, um, go to Canvas, pull Canvas up. Let me see, here comes Ariana. Let me see if I need hers. Nope, she did hers. Okay. Good morning. I was just inviting everybody to go to Canvas and let's see what else we got to do. Okay. All right. All right. Good morning, Maxwell. All right. Of you, because only two of you, three of you have done the assessment. So let's start with the assessment in the gizmo, and then so I'm going to give 10 minutes for you to do that. And then while you're in gizmo, let me also explain how you were supposed to do the last page of the assignment. So I'm going to bring that up as well. All right, almost everybody's here. All right, so everybody except Natalie, Kashawn, and Ariana have to do the assessment um, page. Let me share so you know what I'm talking about. So log into the gizmo, the dichotomous key gizmo, and you need to do okay, you need to do the assessment, but I don't want to be there. Okay. Manage class. That's all right. These questions here, these assessment questions. Let me log in. Here we go. One more. All right. I think we got everybody now. All right. Good morning, Landon. All right. So make sure that so all of you except for the three I called, need to do the assessment questions. There's just five of them, but they are part of the grade 5 points on the worksheet grade. In addition to that, let me show you how you were supposed to do. Before you start doing that, let me show you how you were supposed to answer the last part of this question. All right, so this one down here, because some of y'all are trying to leave this out, this part down here. Okay, basically you are doing what was already done on the page for the albatross. You're going to pick any one of the other organisms, and you are going to create a key that identifies them. But what I want to show you is that you're always going, so the albatross, let's say, let me pick the next one. Let's pick the snake. All right. It doesn't matter which snakes, you're going to take pictures of four of the snakes. And for all four of the snakes, they're all going to start off with the same two lines. So that should be your first two lines always. And then it'll end go to two and then go to three, the way it has on the worksheet. So after you've done that, then your next two, whatever you put in 2 and 3, should take you to the name of the organism. So I'm going to take this one for example. So you would put these two lines in the first two boxes. Okay, so I'm going to show you. It's the same thing for all of them. The same two lines. It doesn't matter which one you pick. It's going to be the same two lines. All right. So say you pick this particular picture, and you have these two. So the snake, and then rattles on the end. So yes, it does. And so then for that one, you would say go to 2. Okay. All right. It has a rust-colored stripe down its back. Yes, it does. And so that should be in your next line. You can have these two statements in your number 2. And this one at the end of this line, it'll take you to the name. So that's what goes in the box. So you already named the first one. Okay. Then you have to go back and find the name of your, so if at the end of the line for 3, that should, let me go back. How do we go back without going back? All right. So if I pick the next picture, all right, let me do this. No, I don't want to do that. Let's pick, oops, picture B. All right, so this one, all right, so this one, it does not have a rattle at the end. So on that first box at the top, you would have said go to 3. Okay. And then on this one, the snake does not have a bright yellow or red band. It has bright yellow and red band, so you would click that. So that might be your second line. And then you're looking at which colors are touching. Okay, this one has where the black is touching red. So black, red bands touch the red. So that's that one. So at the end of that line, in the box on the side, you got the name of the snake. Okay, so that's what you have to do for the last page for this one. Okay, don't leave this out. That's 10 points to get the 4 pictures. You don't have to do all 8, just do 4 pictures. And then you want to complete this box. It says repeat step 2 for you're going to repeat this box for the 4 pictures that you pick. Okay. All right. While I have you, let me just do everything while I have you looking at Canvas. All right. Go to your home page. When you finish fixing that up, you have a worksheet to do, a practice worksheet. We are practicing every chance we get because we're 1 month away from end of course tests. All right, so on your to-do list, you have something called a dichotomous key and cladogram practice. Download that. And actually, I wanted to show you a video before you did this. So just download it, and I'm gonna give you 15 minutes to finish up the other one, and then I'm going to show you the video because you need the video for the second part. The first part is just a review, a repeat of what you're doing, but the second part is new information. So just download that. We're going to get to that. So I'm going to give you 15 minutes to do the quiz. Make sure that you on the last page of the worksheet because here again, I've only got 3 worksheets in and it is already past due or it's due today. So let's make sure that we're not getting behind, we're not getting zeros, we're not losing points for things being late. All right, so I'm going to stop talking, do attendance, let you finish your gizmo, and then I'm going to come back and talk about this worksheet. If you get to, before you do the worksheet, if you're finished with everything else, before you do the worksheet, read the module on, okay, let me pull this module up. There are a couple of you who are finished with everything, so you need to, before you do the worksheets, you need to look at phylogeny and cladograms. So that's what you should read. Phylogeny and cladograms. That's where we are in Canvas. In particular, we are going to look at doing one of these. So the activity today is going to require that you draw one of these. So you need to read this over first before trying to do that worksheet. But again, we're going to watch a video first and then come back to this. All right, so do your assessment and then go read Canvas and download the worksheet. That's what we need to do. And I got folks still looking at me and not doing what they're supposed to do. Folks, this is Friday. Grades get uploaded today. So we want to make sure that there's no zeros or everything is done the way it should be done. Got all the points you need to get. Yeah. All right, Landon. Let's see, Landon, Maxwell, Zayla, and Isabella. Y'all still need to do the quiz. Score is being added to your worksheet score. Okay, let me refresh and see what's what. Right now, saying 5 out of 9. Yes, you did. All right, so the only person I'm missing is Landon. Thank you, everybody else. All right, 10 more minutes, and then I'm going to show the video and talk about doing that worksheet. So if you're already finished with this, you should be reading phylogeny in Canvas. Also, just a reminder, because milestones are coming up, you should also always be reviewing vocabulary, vocabulary, vocabulary. Always, always, always. You know your vocabulary, you can understand what the question is asking, and have a better chance of even guessing right if you need to. I'm not going to ask again. All right, since everybody has completed their quiz, get you to finish your worksheet later. All right, please give the video your attention. What happened to the sound?
Hey, it's Professor Dave. I want to tell you about the tree of life.
He knows a lot about the science stuff. Professor Dave explains.
By now we know a lot about natural selection and the ways that populations
He's
of
going to start
organisms
off with a
can
good
change
review, so
dramatically
pay
over
attention to
long
that
periods
too.
of time, just like slow geological processes that create mountains and canyons. Over the 500 million years since the Cambrian explosion, an unbelievable array of organisms has come to be, most of which are gone, but plenty of which are still here. We can explore the world and find strange creatures in the jungle and at the bottom of the ocean, and we can look at fossils to see what once was. So how do we keep track of all these different kinds of life? Which creatures are more closely related and which are more distant? To stay organized, we use something called the tree of life. We can think of the trunk of this tree as the unicellular common ancestor of every living thing in history. Of course, this is long extinct, but it produced other organisms which are represented by different branches. And these, in turn, produced other organisms, and so on, until millions of years later, here we are, along with whales and birds and porcupines and bears. The process by which one species produces a new species is called speciation, and this is the bridge between microevolution, which looks at changes in allele frequencies, and macroevolution, which is a broad pattern that produces new organisms that look totally different from pre-existing ones. We have a way of classifying an organism that tells us exactly how it is related to everything else, how recently or distantly, and every organism belongs to a particular species. These are groups of populations that have sufficiently similar genetic material such that they are capable of breeding to generate viable, fertile offspring. If two organisms can do this, they are of the same species. If not, they aren't. But before we start with the trunk of the tree of life, let's quickly recall exactly what happened in the early history of life on Earth. We've already talked about
Commercial.
From idea to submission, empower students to do their best work with Grammarly's comprehensive AI writing assistance. What if they could jumpstart ideas for any assignment?
That took long.
We've already talked about the origin of life, but let's review a few points to put things in perspective. From the famous Miller-Urey experiment, we saw how conditions on the early Earth, just after it cooled enough for liquid water to exist, were such that amino acids and nitrogenous bases could form spontaneously. These were able to polymerize to form long chains, and when some of these were by chance encapsulated in a self-generating membrane, like the way soap micelles form, the first protocell was born. Once nucleic acids became self-replicating, the concept of inheritance took hold. We also discussed how multicellular life arose from unicellular life, which resulted in an even greater variety of organisms. This is admittedly a speculative series of events, and one could go into much greater detail on any individual step. But it is rooted in firm science and testable hypotheses. So let's move to the time period where an extensive fossil record begins. We can look at fossils to learn about living organisms that existed at any point over the past several billion years, which gives us incredible insight into the history of the Earth. We divide this history into different eons, beginning with the Hadean eon, where the Earth was still a hot ball of molten rock. In the Archean eon, prokaryotic life arose, living alone for 1.5 billion years. This is when the Earth became covered in oxygen as the product of photosynthesis. In the Proterozoic eon, eukaryotic life evolved through endosymbiosis, and eventually multicellular eukaryotic life through cell specialization. This eon ends with the Cambrian explosion. And lastly, the Phanerozoic eon starts a little after animals show up on the scene and is divided into the Paleozoic, Mesozoic, and Cenozoic eras. This whole eon is around 500 million years long, starting just before animals make it onto dry land. Dinosaurs dominate the Mesozoic era, and humans show up only in the last sliver of the Cenozoic era. The boundaries between these eras and eons mark huge extinction events that can be seen in the fossil record, and we continue to examine fossils to learn about life from all periods of biological history. Now that we are up to speed with the history of life, we want to know about the phylogeny of various species. This is their evolutionary history, or ancestry, and the discipline of taxonomy is what we use to classify every species in the context of its ancestry.
Next commercial.
We're a bicycle company, but we try to utilize technology in any way we can to keep.
For greater context, we look at the tree of life. This tree has many branches, where different species evolved from a common ancestor. The more recently two species converge as you go down, the more recent their common history, and the more closely related they are. As you continue to go down the tree, species become less and less related. So humans and chimpanzees, whose branches are very close to one another, diverged from a common ancestor only a couple million years ago, whereas humans and jellyfish are much more distantly related, having diverged hundreds of millions of years ago, when all life was in the sea. If we get all the way to the bottom, the trunk of this tree marks the beginning of life on Earth, a single-celled organism that everything alive today is descended from. Since we don't know precisely what that was, we start with what we know, and at the most basic level, we consider 3 domains of life. These are bacteria, archaea, and eukarya. Bacteria and archaea are the unicellular prokaryotes we talked about, and eukarya is all eukaryotes. This means unicellular protists as well as all multicellular life on Earth, including every plant and animal there is. Within the domain eukarya, there are several kingdoms. Animalia contains all animals. Plantae contains all plants. Fungi contains all mushrooms and molds. And Protista contains all the rest, although many biologists don't recognize this as a valid kingdom any longer. Within each kingdom, there are several phyla. Within the animal kingdom, there are 9 major ones. There is the phylum Arthropoda, which contains all kinds of bugs and lobsters and creepy crawlies. Mollusca, which contains octopi and snails and other such things. And most notably, there is Chordata. This phylum includes any animal with a spinal cord, and the divergence of vertebrates and invertebrates was a major step in evolution. Within each phylum, we can find different classes of organism. Chordata contains the class Reptilia, which are reptiles like crocs and snakes and lizards. Amphibia, which are amphibians like toads and frogs. And Mammalia, which are all the mammals, from kangaroos to elephants. Humans belong to Mammalia, and within this class there are a number of orders. The order Cetacea contains all the whales and dolphins. Carnivora contains things like bears and weasels. Then there are the primates. That's got everything from orangutans to lemurs, and humans are in there too. Within the order of primates, there are several families. The family Hominidae contains all the great apes, so that's us again. Within Hominidae, every organism belongs to a particular genus, and that's where we diverge from the apes. Our genus is called Homo, which means man in Latin. Within a genus, there are several species, and all the species within the genus Homo are now extinct, except for Homo sapiens, and that's us. The species that came before us, Homo erectus, Homo habilis, and many others, are all gone. And Homo sapiens, which means wise man, sits at the very top of the tree, the only species to have evolved an intelligence that spawned complex civilizations and information storage, first as written language, and eventually the omnipresent internet, which you're using right now. So every species can be classified, and there are mnemonic devices that can help us remember the different tiers of categorization. Do kangaroos prefer cake or frosting, generally speaking? Or did King Philip come over from Great Spain? You can even make up your own. To review, we humans are collectively the species Homo sapiens. We belong to the genus Homo, the family Hominidae, the order Primates, the class Mammalia, the phylum Chordata, the kingdom Animalia, and the domain Eukarya. We diverge with our path at some point, whether very recent or very distant, which means that every living thing is related in some way. To see precisely how related two species are, we could use sophisticated techniques like ribosomal RNA sequencing, or we can simply examine homologies. These are similarities between organisms, be they genotypic or phenotypic, and they typically suggest common ancestry, as an organism's evolutionary history is documented in its genome. But to get into these details for specific animals,
All right, so he's going to advertise the next segment. So a lot of that was review for evolution, a lot of it. But what I want to go back and do is look at mnemonics. So I want you to write these down, and then I'm going to invite you to make one of your own. So it is important, extremely important, because it's a test question on the milestone as well as a unit test, that you know these in order. So you've already had a worksheet that asks you which one falls within the other one. So you need to know these in order so that you can be able to distinguish which one is which. So notice the first letter of each of these words in the mnemonic starts with the first letter for the classification system in order. So D for domain. So do kangaroos prefer cake or frosting? Generally speaking, write that down. So that's something, and then you want to create something that you can remember easily. So this is an example, write it down. And then I'll switch to the second one and then ask you to write one of your own. Not fond of the last one that they did. All right, the second one is the one that I learned when I was coming through school. Did King Philip come over from Great Spain? All right, so you can write that one down, and those are examples. And then they came up with a third one. Not real fond of that one because it's kind of weird. But again, you need to make up something that will allow you to remember the classification headings in order. Now in earth science, you have one with the planets, this one, so that you can learn this in order. And again, it is important that you know the headings in order. All right, so I'll give you another minute to write that down. And then I'm going to switch to the worksheet and explain what you need to do with those. All right. Again, those are just examples. You need to make up one that will of your own. I might even ask you for one on a worksheet. All right. Canvas, Canvas. Let's look at Canvas. So I do want you to read this page. You do need to know what phylogeny means. It is the study of evolutionary relationships among organisms. So it's kind of like the family tree that you have here, except it looks more at the characteristics that an organism has, and they're comparing their, so read that over. Most specifically, I want you to look at this. All right, this is very simple, and the activity that you have on your worksheet is also very simple. Phylogeny says there's a common branch, so you want to start with one solid common branch. In this one, everybody's a vertebrate, so that's why they're all on the same branch, but they have differences. And over here on the side, the right side, they've explained what the differences are. Some have bony skeletons, some so these two have bony skeletons, the shark and the bony fish. They have limbs. So as we go up, so these guys don't have limbs. These guys up here have limbs. So that's a differentiation from being a vertebrate. An amniotic egg is a characteristic that the amphibians have and the reptiles. And so everybody up on this end of the branch has that in common. Amphibians, reptiles, mammals, they all have an amniotic egg, but what is also different, which puts the mammal at the top, is that it has hair, not feathers, not scales, it's got hair. So that's how it ends up on the end. All right, and I said that so come back to this and use that as an example. So let's look at the worksheets that you have to do. All right, you have two worksheets. The first one, this one is easy because you have, again, the 4 pictures, and you're going to use this key, and underneath each picture, you're going to write the name of the organism described. Again, they start off with, does it have a speckled breast or does it not have a speckled breast? Remember, doing dichotomous keys always is a yes or no answer to the question. All right, down here you have to draw. So things that are stationary items. So your solid branch that everything is going to extend from is stationary items. So you need to label that at the base of your line. You want to say that these are all stationary items, and then you want to try to put them in order. Look at some of the things that might have a origin in common, and let those branch together. And then things that are more complicated till you get to the top of your stationary branch to something that is in a unit all by itself. So you want to draw a picture here. So you like the one in Canvas, you want one solid line, and everything else is branching from that based on their origin. Okay. All right, let's the next one is you're going to write a description, kind of like what he talked about in the video. It says list the features that define each one. So what makes, how do we classify an animal as an animal and not a fungi? What makes a fungi and not an animal? What makes a protist, and you want to use that lines up at the top for your protista. And how is that different from a plant? How is that different from prokaryotes? Down here to the bottom, you want to go across the row and just put a check mark. You're going to have at least 3 check marks on each row. Okay, so you might, so you need to know endothermic means that they're warm-blooded. Ectothermic, they're cold-blooded. Do they have dry scales on the outside? Do they have wet scales? Do they have a placenta, which means do they give birth to live young? Those are the only organisms that have placentas. Do they have feathers? Do they lay eggs with hard shells? Do they lay eggs in the water? Do they have lungs throughout their life cycle? So you want to just put a check in the box if they have that characteristic. All right. So all of these are in the animal kingdom. They are actually all in the vertebrate phylum, but they're different. So how are they different? And you're going to put a check in each box. All right. So I'm going to stop talking so that you can get started doing that. All right. This is not due till next week. So if you have not done your gizmo, uh, turned in that, please make sure you turn that in first because that'll be late. This is not due until next class. All right. Any questions, please ask. So again, we want to read. We want, if you need backup information, you want to make sure that you are reading. No, we're not doing that. Sometimes hitting the back button will work and sometimes it doesn't. All right, so this is the page in Canvas that we are basing today's activities on. So if you haven't had a chance to read it, you want to read this first. The vocabulary words are phylogeny, cladograms, and evolutionary origins. If you have questions, please ask. Forgetting I'm sharing. With your cladogram, you want to just create your, it needs to look like this. Okay, so you're not drawing lines from the words. You are creating a solid line at the base, like the same way this one at the base says vertebrate, yours at the base will say stationary items. And then you want to draw lines the way this one is. All of the common, and this one says common ancestry is that they are vertebrates. The common ancestry on the things that you have on your papers, they're all stationary items. Next after that, again, look at the things that they have in common. See if any of them can be branched together. For example, some of them are derived from wood, from a tree. Some of them are derived from plastic or rubber. Some are derived from chemicals, so they have different origins. Base your line on their origin and have them branched according to who's related to who. And if necessary, practice on this first before you practice on your paper. All right, here's a vocabulary word up here, synomorphy. This page will help you with the second worksheet. Mhm. Good. Oh. Because Sean, the Google link that you included on your worksheet didn't work for me. Is there another way that I'm gonna send this back so that you can possibly include a different way to link your document, your extra page? Because the screenshot is of the assessment. I didn't need that because I could look that up. What I need is this copy of your um, question number 2 that you created. And the link doesn't work. So I'm going to send this back. I'll grade it as is, but I'll send it back so that you can uh, include that document. I'll try it again, but I don't think it's. Never mind, I tried it a different way. It's not correct, but I found it. I never mind, Deshaun. Kashawn, I I'll take what you sent. It's not a dichotomous key though. Next. Okay. All right, folks. Still quite a few of you have not turned in your dichotomous key gizmo. I have everybody's quiz score, but you need to turn in the worksheet. That being said, it's almost time to go. If you have no questions of me, you all have a great weekend.